Hello and welcome to Leo the Math Tutor. Today we are going to take a look at the 2019 AMC-8 math competition. So this competition is to be completed in 40 minutes. So let's get started with problem number 1. Problem number 1 says, Ike and Mike go into a sandwich shop with a total of $30 to spend. Sandwiches cost $4.50 each and soft drinks cost $1 each. Ike and Mike plan to buy as many sandwiches as they can and use the remaining money to buy soft drinks. Counting both soft drinks and sandwiches, how many items will they buy? So, first to determine how many sandwiches that they will buy, we need to calculate that. $4.50 times 6 is equal to 27. So if they spend $27 buying 6 sandwiches, that leaves them with 30 minus 27. So $3 for soft drinks, which gives them 3 soft drinks. So 6 sandwiches plus 3 soft drinks gives them a total of 9 items that they purchase. So the answer for number 1 is D. Let's go to problem number 2. 3 identical rectangles are put together to form rectangle ABCD, as shown in the figure below. Given that the length of the shorter side of each of the smaller rectangles is 5 feet, what is the area in square feet of rectangle ABCD? So we are told that this length over here is 5 feet. So this length is also 5 feet. And that shows us that 2 of these shorter sides fit into one of the longer sides. So the longer side is 10 feet, shorter side is once again 5 feet. So in total, the dimensions of this larger rectangle ABCD is 10 feet by 15 feet, giving us an area of 150 feet squared. Answer for 2 is E. Problem number 3. Which of the following is the correct order of the fractions 15 over 11, 19 over 15, and 17 over 13 from least to greatest? So, with problem number 3, first we need to understand how to compare fractions from least to greatest. So what I will do to make this process a little simpler is convert each of these improper fractions into a mixed fraction. So 15 over 11 is equal to 1 and 4 over 11. 19 over 15 is 1 and 4 over 15. And finally, 17 over 13 is 1 and 4 over 13. So as we can see, each of these fractions is 4 as the numerator and a different number as the denominator and with a 1 in front. So I'm going to subtract all the 1s. So I'm going to subtract the 3 1s from each of these fractions and only compare 4 over 11 to 4 over 15 to 4 over 13. Now, one simple trick we can use is understanding that as the denominator of a fraction gets larger, the value of the fraction decreases. Take, for example, 1 over 1 versus 1 over 10. We know that 1 over 1 is greater than 1 over 10. And subsequently, 1 over 10 versus 1 over 100, 1 over 10 is obviously larger than 1 over 100. So knowing this, what we can do is we can determine that the smallest fraction will be the one with the highest denominator, giving us 19 over 15 as our least, then 17 over 13 as the middle, and finally 15 over 11 as our greatest. That lets us know that the answer to question number 3 is equal to E. Problem number 4. Problem number 4 says quadrilateral ABCD is a rhombus with perimeter 52 meters. The length of diagonal AC is 24 meters. What is the area in square meters of rhombus ABCD? So, this rhombus has a perimeter of 52 meters. So we're going to divide this 52 meters by 4 different sides. And these 4 sides are equal. So each side has 13 meters. 13 meters. So each of the sides, 4 sides of the rhombus is 13 meters. And let's draw a line from A to C. And we know that A to C is 24 meters. 24 meters. Now, this 24 meters, I'm going to split in 2 by drawing a line from B to D, like this. Now, we have this triangle over here that is highlighted in yellow. And this yellow triangle has a dimension of, let's draw the triangle over here, 12 and 13. And this is a very common triangle. It's a 5 by 12 by 13 triangle, which we can figure out using the Pythagoras theorem. So given these dimensions, the area of the triangle is 5 times 12 times 1 over 2, which is 30 meters squared. And as we can see, we have 1, 2, 3, and 4 of these triangles. So 4 times 30 meters squared equals 120 meters squared. So the answer for question number 4 is D, 120. Look at number 5. Number 5 says, a tortoise challenges a hare to a race. The hare eagerly agrees and quickly runs ahead, leaving the slow-moving tortoise behind. Confident he will win, the hare stops to take a nap. Meanwhile, the tortoise walks at a slow, steady pace for the entire race. The hare awakes and runs to the finish line only to find the tortoise already there. Which of the following graphs matches the description of the race, showing the distance d traveled by the two animals over time t from start to finish? So we have a lot of information in this question, so let's break it down piece by piece. The first important piece of information is that the tortoise walks at a slow and steady pace for the entire race. So we know that this distance time graph will feature a line, a straight diagonal line, as one of the distance and time narratives. Now, another piece of information we need to consider is that the hare takes a nap. So it runs really fast, it takes a nap, and then it runs really fast again. So what happens when it takes a nap? The time keeps moving, but the distance doesn't move. That means that the line should go straight horizontally, as the distance doesn't move along the up and down axis, the y-axis. So just off those two descriptions, we can determine that the only two graphs that could possibly represent this timeline is A and B. Now, the final piece of information that will tell us which one of these two graphs is the correct answer is that the hare runs really fast only to find out that the tortoise is already at the destination. So that means the peak will be reached by the straight line before it's reached by the hare. And using that information, we can conclude that the answer to this question is, in fact, B and not A, because we can see that the straight line reaches the destination before the other one does. So the answer for question number 5 is B. Question number 6. There are 81 grid points uniformly spaced in the square shown in the diagram below, including the points on the edges. Point P is in the center of the square. Given that point Q is randomly chosen among the other 80 points, what is the probability that the line PQ is a line of symmetry for the square? So for this question, let's first determine the different lines of symmetry. So we have a line of symmetry going along these two diagonals. We have another line of symmetry vertically and horizontally. So there are the lines of symmetry that we need. Now, the only thing we need to determine is, this is a probability question, and with probability, a probability of something happening is the number of times it satisfies the condition over the number of options that you possibly have. And so it says it's chosen randomly among 80 points. So we know the denominator is 80. And let's see how many points are on these points of along these lines of symmetry. So we have 1, let's use a different color. We have 1, 2, 3, 4. Remember, the center point P is not included in one of our 80 options. So we have 4, 5, 6, 7, and 8. So using that, we know that there's 8 along this, 8 along this, and 8 along this. So 8 times 4 gives us 32 over 80 as the probability. Now we can reduce this fraction. We can divide the top and the bottom by 16 and get the answer 2 over 5. And 2 over 5 is C. So the answer for problem number 6 is C. Problem number 7. Shauna takes 5 tests, each worth a maximum of 100 points. Her scores on the first 3 tests are 76, 94, and 87. In order to average 81 for all 5 tests, what is the lowest score she can earn on one of the other 2 tests? So in order to make room for her to score the lowest possible mark on one of the 2 remaining tests, she should score the highest possible on the other one. So the highest possible is 100. So now we know 4 out of the 5 test scores. So let's write those down. 76, 94, 87, and 100. Now we need to find this last number and divide it by 5 tests, because remember, we want to find the average of the 5 tests, and the average is 81. So let's multiply 5 times 81. 5 times 81 is equal to 405, equals 76 plus 94 is equal to 170, plus 87 is 257, plus 100 is 357. So 357 plus this unknown score. And this unknown score is 405 minus 357. So we know that the final score that she must receive is equal to 48. And 48 is answer A. So the answer for question number 7 is A. Looking at problem 8, Gilda has a bag of marbles. She gives 20% of them to her friend Pedro. Then Gilda gives 10% of what is left to another friend. Finally, Gilda gives 25% of what is now left in the bag to her brother Jimmy. What percent of her original bag of marbles does Gilda have left for herself? So the thing with percentages is that these percentages scale based on how much she has remaining. So that's the key thing to keep in mind. So originally, she has 100%. But what happens? She gives 20% away to her friend. So now she has 80%, right? Now, out of that 80%, remember, it's what she has remaining. She gives 10% of that 80% away. So what that means is she keeps 90% of the 80%. So what is 80% times 90%? Sorry, what is 90% of 80? Of 80 is equal to 72%. So now she has 72% of her original amount remaining. Finally, she gives away 25% of the 72%. So using the same logic, we will do 72% times 75%. So we need to know what 75% of 72 is. And 75% is a very easy fraction. It's 3 over 4. So 72 times 3 over 4, I can cross out 1 and 18. 18 times 3 equals 54. So finally, we know that she has 54% of her original amount remaining. And that tells us that the answer to question number 8 is E. Looking at problem number 9. Alex and Felicia each have cats as pets. Alex buys cat food in cylindrical cans that are 6 centimeters in diameter and 12 centimeters high. Felicia buys cat food in cylindrical cans that are 12 centimeters in diameter and 6 centimeters high. What is the ratio of the volume of one of Alex's cans to the volume of one of Felicia's cans? So this one is a question about ratios and the volume, knowing the volume of a cylindrical can. So a cylindrical can looks something like this. So in this situation, what we need to do is first determine the equation for a volume of a cylinder. So the volume of a cylindrical can is equal to area of a circle, which is pi times radius squared times the height. So pi times radius squared times the height. Now, in a ratio, this is something we have to keep in mind. What's going to happen is we'll find the volume of Alex's cans and compare it to the volume of Felicia's cans. Now, with a ratio, we can divide each side by a common factor. And we know that the equation for volume is pi times radius squared times height. So since radius and the height is unique to the person, so Alex has a can with a radius of 3 centimeters and a height of 12 centimeters, and Felicia has a different can with different dimensions. We can't factor out radius or height, but pi is a constant, so we can factor out the pi. So what the ratio for this situation will actually be will just be the radius squared times the height compared to the radius squared of Felicia's cans times the height. So the radius of Alex's cylindrical cans is 3 centimeters. So 3 squared is 9, and the height is 12. So 9 times 12 is equal to 108. Felicia's cans has a radius of half of 12, because 12 is the diameter, so 6. 6 squared is equal to 36, and the height is another 6 centimeters. So 36 times 6 is equal to 208. So, sorry, not 208, 216. That is my mistake. So Now the ratio is 108 to 216. So the ratio of the volume of Alex's cans to the volume of Felicia's cans is, we divide 1 to 2. So for question number 9, the answer should be B, 1 to 2. Let's look at problem number 10. The diagram shows the number of students at soccer practice each weekday during last week. After computing the mean and median values, coach discovers that there are actually 21 participants on Wednesday. Which of the following statements describes the change in the mean and median after the correction is made? So let's just write down these numbers beside the bar graph. So on Monday there are 20, on Tuesday there are 26, on Wednesday there are 16, Thursday there are 22, and on Friday it is reported that 16 players showed up. So we have these numbers, and all we know is that on the second set of data, we need to replace the 16 on Wednesday with 21 because there are actually 21. So there are two ways to solve this question. And since this is a competition, we want to solve this as quickly as possible. So this is the quickest way that we can solve this problem. This set of numbers will give us an average. And to find the average, we need to add all of them and divide it by 5. But this is the thing. We'll just call it average number 1. What happens? What happens if we change Wednesday from 16 to 21? The sum of the set of numbers increases by 5. And when it increases by 5, we still have to divide by 1. That means that average number 2 is 1 greater than average number 1, because the total sum is 5 greater than the first set of numbers. Now, in order to solve the second part, how the median value changes, the median value changes if the order of least to greatest changes. So does the order of the least to greatest change? Let's take a look. On the first set, 16 and 16 are tied, and then it's 20, then 22, and then 26. So the median value is the one in the middle, so 20 will be our median. Now what happens if, instead of 16, we put in a 22? So if it's 22, 16 is number 1, 20 becomes our number 2, and 21 becomes our number 3. So our average number 2 is 1 greater than average number 1, and our median is now 21 instead of 20. So which answer describes that situation? The mean increases by 1 and the median increases by 1 as well, which lets us know that the answer for problem number 10 is equal to B. So we got problem number 11. The 8th grade class at Lincoln Middle School has 93 students. Each student takes a math class or a foreign language class or both. There are 78 8th graders taking a math class and 54 8th graders taking a foreign language class. How many 8th graders take only a math class and not a foreign language class? So this question can be solved really quickly by summing the number of students in the math class and a foreign language class. So 70 plus 54 is equal to 124. Now, if every student could only take one class, then apparently there should be 124 students. But it tells us that there's 93. So what does that mean? That means the 124 minus 93 students are taking both classes. So that's 31 students taking both. Now, the answer we want to find is how many 8th graders take only a math class and not a foreign language class. So we know how many are taking a math class, which is 70. And we know out of those 70 that 31 are taking also a foreign language class. So that means that 39 are only taking a math class. And the answer for problem 11 is D. Problem number 12. The faces of a cube are painted in 6 colors: red, white, green, brown, aqua, and purple. 3 views of the cubes are shown. What is the color of the face opposite the aqua face? So if we look at these 3 cubes, let's see the different colors that we know are on the faces. On cube number 1, we see brown, red, green. Cube number 2, we see brown, white, red. And on the third, we see red, purple, and green. Now, we want to know what's on the opposite face of an aqua. So since we don't know where the aqua face is, we're going to have to figure that out. So thankfully, they actually stayed consistent by rotating the direction of the text. So what I mean is blue and red are on the top and on the front on cube number 1. But sorry, B is brown. So brown and red are top and front respectively on cube number 1. Meanwhile, brown and red are front and right on cube number 2. So what does that tell us? That tells us that in comparison, when brown is on top and red is on the right, the white should be at the front. So if you rotated this 90 degrees that way, it tells us that on the side left over here on cube number 1, the left side is white. I'll write that a little better. The left side of cube number 1 is white. Now the third cube should reveal to us the final position of aqua. So on cube number 3, we see red being on top, and with red being on top, we see purple and green on the front and right. So we can't see the left, we can't see the back, we can't see the bottom. Now this is the thing. We've already established where brown, green, white, brown, green, white, and red are. So in this case, it only shows us where red is, which means that the two remaining faces that we haven't established are shown in figure number 3. So green is matching here and the red is matching here. So what happened? What happened was that cube number 1 was flipped up this way 90 degrees so that red went on top and green is on the right, which is consistent with number 1. So that means the bottom face on cube number 1 is purple. So let's look back at cube number 1. We know that the front is red, the right is green, the left is white, the top is brown, and the bottom is purple. So there's 6 sides to a cube. We know where the 5 colors are. So aqua is very clearly on the back. Aqua is on the back. And the answer should be, what is the opposite face of the aqua face? It is red. So the answer to question number 12 is A, red. Problem number 13 says a palindrome is a number that has the same value when read from left to right or from right to left. For example, 12321 is a palindrome. Let n be the least 3-digit integer which is not a palindrome but which is the sum of 3 distinct 2-digit palindromes. What is the sum of the digits of n? So this is what we'll do. With problem number 13, let's just think about, there's not a lot. Let's just think about the 2-digit palindromes that we could possibly add together. We have 11, 22, 33, 44, 55, 66, 77, 88, 99. Now, something that you'll notice is that the increments between each of these palindromes is just 11. Each time we just add 11 and we get the next palindrome. What that tells us is, take for example, 11 plus 99 is 110. What about 22 plus 88? It's still 110. And why is that? It's because 22 is 11 plus 11 and 88 is 99 minus 11. So 11 plus 11 plus 99 minus 11. The 11s cancel out and we just get 11 plus 99. So that pattern lets us know that no matter what 2 pairs that we pick, the sum will always be equal to 110. So since the sum of the 2 palindromes, 2 distinct palindromes, 2-digit palindromes, is always 110, what we know is that the sum of the digits is 1 plus 1 plus 0, so 2. The answer to problem number 13 is A. Problem number 14. Isabella has 6 coupons that can be redeemed for free ice cream cones on Pete's Sweet Treats. Okay. In order to make the coupons last, she decides that she will redeem one every 10 days until she has used them all. She knows that Pete's is closed on Sundays, but as she circles the 6 dates on her calendar, she realizes that no circled dates falls on a Sunday. Perfect. On what day does Isabella redeem her first coupon? So, with this question, one thing that we realize is that she picked 6 dates and none of them lands on a Sunday. But there's a distinct answer to the day that she redeems her first coupon. And what that means is that there is only one possible day where it satisfies the condition that the next 6 dates that she picks, being in 10-day increments, is not on a Sunday. So if we know for sure that left to right is always going to be the same. So if you know that the 6 dates that she picks are gonna be set in stone because we need to find an answer for this question. That means that if we read left to right, it should be the same as reading right to left, just in the opposite order. So I'm gonna work right to left this time. We're gonna find the last day that she redeems, her 6th coupon. And how I'm going to do that is I'm going to pick the date that she does not ever want to pick, which is Sunday. So what happens? What needs to happen for the inevitable, terrible Sunday to be the day that she picks to use her coupon because the store is closed? So what needs to happen for her to try to use a coupon on a Sunday? Let's count back. So if she wants to use a coupon on a Sunday, just if, she doesn't, but if she does, we need to go 10 days back. So 1 is Saturday, 2 is Friday, 3 is Thursday, 4 is Wednesday, 5 is Tuesday, 6 is Monday, 7 is Sunday, 8 is Saturday, 9 is Friday, and Thursday is the 10th day prior. So that means that just if she wanted to redeem a coupon on a Sunday, then she should redeem her coupon on a Thursday. But she doesn't. So what does that tell us? That tells us that in worst case scenario, she wants to make sure that she does not have to use a coupon on a Sunday and have any left over. Because if she uses a coupon on a Thursday and she has one more coupon left over, she needs to circle a Sunday. So what we did here was we went from Sunday back to a Thursday. So basically we counted 3 days back. Thursday, 1 would be Saturday, 2 would be Friday, and 3 would be Thursday. So we counted 3 days back. So let's keep using this. Let's count another 3 days back. Thursday and go 3 days back. Wednesday, Tuesday, Monday. So Monday. Now what about after Monday? Let's go 3 days back again. So on Monday, we go 3 back. Sunday, Saturday, Friday. Okay, Friday, go 3 days back from Friday again. Thursday, Wednesday, and Tuesday. And on Tuesday, let's go back 3 days again. Monday, Sunday, Saturday. Perfect. And after Saturday, let's go 3 days back again. Saturday, back 3. So Friday, Thursday, and Tuesday. Friday, Thursday, and Wednesday. That's my mistake. It's not a Tuesday. It's a Wednesday. And what happens when finally we go back 3 days from a Wednesday, we get Tuesday, Monday, and Sunday. We don't want a Sunday. So what that means is that the 6 days that she circled are in between the 2 Sundays that she wants to avoid, letting us know that the first circle is on a Wednesday. So the answer for problem number 14 is C, Wednesday. Let's go to problem number 15. On a beach, 50 people are wearing sunglasses and 35 people are wearing caps. Some people are wearing both sunglasses and caps. If one of the people wearing a cap is selected at random, the probability that this person is also wearing sunglasses is 2/5. If instead someone wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? Right, so this is very similar to question number 11 that we solved. So with question number 11, we determined that we can just find the number of people in each scenario and the number of people doing both scenarios. So let's do the same thing with problem 15. With problem 15, 50 people are wearing sunglasses and 35 are wearing caps. And it says if one of the people wearing a cap is selected at random, the probability that this person is also wearing sunglasses, there's 2 is 2/5. So that means that 2/5 is equal to, multiply each of these by 7, 14/35. So that tells us very clearly 14 people are also wearing sunglasses. 35 are wearing caps, and of those 35, 14 are also wearing sunglasses. So this 14 number are wearing both. So 14 are doing both. And it says if someone were to pick someone at random who's wearing sunglasses, so 14/50 will be our probability that they're also wearing a cap. And 14/50, we can divide the numerator and the denominator by 2. 7/25 is our probability, and the answer is B. Problem number 16. I apologize if I butcher this, but Qiang drives 15 miles an hour at an average speed of 30 miles. Sorry. Qiang drives 15 miles at an average speed of 30 miles per hour. How many additional miles will he have to drive at 55 miles per hour to average 15 miles per hour for the entire trip? Right, so this question, we can solve this really quickly with algebra. So how we're going to do this is first we will establish the relationship between distance, speed, and time. So we know that distance is equal to speed times time. So that tells us that in the first section, when he drives 15 miles at an average speed of 30 miles per hour, he drove for 0.5 hours, right? So half an hour at 30 miles per hour gives us a distance of 15 miles. 30 times 0.5 is equal to 15. So this is a very good equation for us to use. Now, how many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? So an average for the entire trip lets us know that the total, so the sum, this is the symbol for sum of all the distance divided by the sum for all the time is equal to 50. So how do we find the sum of all the distances? So we know that the first distance that he travels is 15 miles. What about the second part? He drives 55 miles per hour for an unknown period of time. So distance is speed times time. So I'm just going to use the variable t to represent our time, our additional time. Now divided by the total time. Remember, in the first part, he drives half an hour. So we need to add that 0.5 to the amount of time he drove extra equals 50 because the average is 50 miles per hour. So now I will multiply 50, 0.5 plus t is equal to 15 plus 55t. What does that tell us? 25 plus 50t equals 15 plus 55t. I move the 50t this way and I move the 15 this way. 10 is equal to 5t. T is equal to 2 hours. So, as you can tell, he needs to drive 2 more hours. But the question wants us to figure out how many more miles does he drive. So 2 hours at 55 miles per hour is 2 times 55, so 110 more miles. He drives 110 more miles in order to achieve that 55 miles per hour over the entire trip. So the answer for question 16 is D. So got problem 17. What is the value of the product? And we see a bunch of fractions. And not only do we see a bunch of fractions, there's a dot here. And that means that, hey, let's pick up on a pattern. Let's pick up on this pattern. And what is the pattern? Let's take a look. First fraction, 1 times 3 over 2 times 2. Okay. Second fraction, 2 times 4 over 3 times 3. Third fraction is 3 times 5 over 4 times 4. So we can expect the next fraction to be 4 times 6 over 5 times 5. And the one after that to be 5 times 7 over 6 times 6. So hopefully you can see the pattern here. And what we can do is we can cancel out a 3 here and a 2 there. We can cancel out the 4 and the 3. We can cancel out the 5 and the 4s. 6 and the 5s, and 7, I'm guessing, with the 7 underneath there, and 6 with the 6 down here. So this trend is going to keep going. So this will cancel with the 97 down here, this will cancel with the 98, 99 will cancel with this, 98 will cancel with this, leaving us with the final product needing to be 1 over 2 times 99, and that is just 50 over 99. So all we have to do is pick up on this pattern and see how easily we can solve problem 17, and the answer to 17 is B. So got problem 18. The face of each of the 2 fair dice are numbered 1, 2, 3, 5, 7, 8. Okay, so there's 6 different sides, but those 6 sides are a little funky. When the 2 dice are tossed, what is the probability that their sum will be an even number? So there's 2 ways to get an even sum. Number 1 is even plus even. Right? So 2 plus 2 is 4, still even. And the second option is odd plus odd. 1 plus 1 is 2. So now, it doesn't work if we get an even and an odd. Why? Because, take for example, 1 plus 2 is 3. So an even plus an odd is still odd. So in order to find the probability that scenario number 1 will happen, we get 2 evens. We have to multiply the probability that we roll an even on the first die and then roll an even on the second die. So this is a a method that we can use to solve most dice probability problems. There are a lot of probability problems, including dice, and this will be a very good approach to practice for these types of questions. So let's try to see how many conditions satisfy. What is the probability that case number 1 will happen? So what is the probability that we will roll an even on the first dice? So there's how many even numbers? There's 2 and 8. So there's 2 even numbers out of 1, 2, 3, 4, 5, 6. So 2 out of 6. That's 1 over 3. And the second dice is the exact same. So we need to multiply 1 over 3 by 1 over 3 and get a probability of 1 over 9. So scenario number 1, very unlikely, 1 out of 9 chance that we roll 2 evens. What about scenario number 2? An odd and an odd. So how many ways can we roll an odd on the first roll? We have 1, 3, 5, and 7. So there's 4 out of 6. So that's 2 over 3 as our probability. And obviously the second dice shares the same chances. So that gives us 4 over 9. A probability of 4 over 9 to get 2 odds, to roll 2 odds. So we need to add those together because they both contribute to the probability of this situation. So 1 over 9 plus 4 over 9 is equal to 5 over 9. And the answer is C. So question 18, answer is C. Let's look at problem 19. In a tournament, there are 6 teams that play each other twice. Okay. A team earns 3 points for a win, 1 for a draw, and 0 for a loss. After all the games have been played, it turns out that the top 3 teams earn the same number of total points. What is the greatest possible number of points for each of the top 3 teams? Okay. So the top 3 teams all earn the same amount of points. So how does that happen? And we want to maximize the number of points that these top 3 teams won. So that means that every team that they play, they need to win as many as possible, right? But we can't forget that if team number 1 wins, then their opposing team loses. So we can't just hand out wins without thinking about how that affects the other teams. So this is what we'll do. We'll distinctly put 3 at the top and we'll put 3 at the bottom. So team number 1, team number 2, team number 3 are going to be at the top. Those are our top 3 teams. And our bottom 3 are team 4, 5, and 6. So what's going to happen? Team 1 plays team 4 twice, team 1 plays team 5 twice, and team 6 twice. So we're going to let team 1 win all those. So that means that team 1 wins 6 times. 6 times 3 is 18. Same idea. Team 1 beats team 4, 5, and 6 each and every single time. That's 6 games. So team 1 has 18 points, team 2 has 18 points, team 3 has 18 points. Now, remember, they play each other twice. Every single team plays each other twice. So that means that team 1 still has to play team 2 twice, and team 1 still has to play team 3 2 times. So in order for that to yield the maximum number of points for each of the teams involved, what we have to do is team 1 and team 2 and team 3 needs to evenly, because they all win the same number of times and they have the same number of points, they need to evenly distribute a win or a loss or a draw. So what's the way that we can maximize our score? So option number 1, they all draw. Team 1 draws a team 2 twice, team 1 draws a team 3 twice. So they play 4 more games and they draw all of them. So 1 times 4 equals 4. So they could each all have 22 points. 18 plus 4 is 22. But what about another option? Team 1 plays team 2 and wins once and loses once. Team 1 plays team 3, wins once and loses one. So what does that do? A win gives a team 3 points. So remember, team 1 plays team 2, wins 1 and loses 1, so that's 1 win. Team 1 plays team 3, wins 1 and loses 1, that's 2 wins. So 2 times 3 equals 6. So as we can see, even though they don't get any points for losing, it yields a better result to win 1 and lose 1 and win 1 and lose 1. So that means that the total maximum number, the greatest possible number of total points for each of the top 3 teams is 18 plus 6, 24. So the answer for problem number 19 is C, 24. Let's look at problem number 20. How many different real numbers x satisfy the equation x squared minus 5 all squared equals 16? So this is a very classic example of how to solve questions involving squares. Now, The reason why squares are so unique is because the square of a negative number is still positive. So what I mean is, if we want to make 16, so let's ignore the thing in the middle, cross it out, replace it with just a star. So a star squared equals 16. That means that a star is equal to plus or minus 4, right? Negative 4 squared is 16, positive 4 squared is 16. Now, let's write down the star again. So instead of just writing star, because we know what star is equal to, x squared minus 5 equals plus minus 4, right? We just replaced the star with a real equation. So x squared minus 5 is equal to plus minus 4. So we have case number 1, x squared minus 5 equals positive 4. That means x squared equals 9. That means x is plus minus 3. There's a second case though. X squared minus 5 equals negative 4. So in the event that x squared minus 5 is negative 4, x squared equals 1, positive 1. So in order for x squared to be 1, x needs to be plus minus 1. Negative 1 squared is 1, positive 1 squared is 1. So we have 2 options and 2 options totaling 4 different options. So how many different real numbers x satisfy the equation? It is 4 different real numbers x. Problem number 21. What is the area of the triangle formed by the lines y equals 5, y equals 1 plus x, and y equals 1 minus x? So let's quickly go over to the right and draw a Cartesian plane like this. This is our Cartesian plane. And we are told that one of the lines is y equals 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 like this. And the second option is, so second line is y equals 1 plus x. Let's draw a better line like this. So y equals 5 is there. Y equals 1 plus x. So if this is 0, 0, this is the origin, then 1, 2, 3, 4, 5. What we know is that when x is equal to 0, y is 1. Okay, so this is one of the points, 0, 1. When x is equal to 1, y is equal to 2. So here, and as you can see, it's just a straight diagonal line like this. So this is our line, and if it's 1 minus x, we can expect it to be just like that. So what we need to do is we need to find the area of the triangle bounded by these three lines. So what we're going to do is we're going to establish what this point and this point and this point is equal to. So this point down here is obvious, y equals 1. Okay, what about over here? What is the x value for this? Because remember, y is equal to 5. It tells us the first equation we know, the first line we know is y is equal to 5. So 5 is equal to 1 plus x. So that means x equals 4. So this is 4 comma 5. This is 0 comma 1. Let's write them in points. And same idea, 5 equals 1 minus x. X equals to negative 4. So this is negative 4 comma 5 like this. So the distance from these 2 points is 8. And the height is equal to 4. And the area of a triangle is base times height times half. So 4 times 8 times 1 over 2 is 16. So the area of this triangle is 16. Answer to problem 21 is E. So got problem number 22. A store increased the original amount of a shirt by a certain percent and it decreased the new price by the same amount. Given that the resulting price was 84% of the original price, by what percent of the price increased and decreased? So that's a very interesting concept. When we increase the price by a certain amount, but then decrease the new price by the same amount, we don't actually end up with our original price. And let's use an example. What would happen if we increase something by 20%? We have 120%, right? Now what about if we decreased it by 20%? What we need to do is we need to find 80% of 120%, not just of 100, 120, because remember that is our new price. So 80% of 120, 80% times there, 120 is equal to 8 times 12, which is 96. So it goes to 96%. So clearly, it doesn't yield 100%. But this is the thing. this is a math competition and we want to solve this question as quickly as possible. And in this case, we could write an equation. We could write an algebraic equation that lets us know right on the dot what that percentage should be. But we don't need to do that. We already tried 20%. And you can see over here, B is 20%, and it only gave us 96%. We want 84. We really want that price to go down. So let's just pick the highest possible answer we have, 40. What happens if we do 40? So it goes from 100% to 140%. And 140% times 140 times 60% is 6 times 14, 84%. Perfect. So we know just by trying just two of these answers that the answer to problem 22 is E. Let's look at problem number 23. After Euclid High School's last basketball game, it was determined that a quarter, 1/4 of the team's points were scored by Alexa, 2/7 were scored by Brittany, Chelsea scored 15 points. None of the other 7 team members scored more than 2 points. What was the total number of points scored by the other 7 teams? So there's 3 groups of people. We have Alexa, we have Brittany, we have Chelsea, and the 7 others. Now, the 7 others are limited. They're limited in the number of points they can score. It says that none of the other 7 teammates scored more than 2 points. That means that the maximum that these 7 other players could have scored is 14. 2 times 7 is 14. Now, we know that Chelsea, no matter what, scored 15. And we know that Alexa scored 1/4 and Brittany scored 2/7. Now, the thing with a basketball game is that you can't score a fraction of a point. You can only score 1 point, 2 points, or 3 points, right? So that means that if Alexa and Brittany scored a percentage, a fraction of it, 1/4 and 2/7, that means that the total number of points that the team scored in this game should be a multiple of 4 and 7. So what we're going to do is we'll find the smallest number possible. The smallest number possible is 4 times 7. So 28 should be the total number of points scored by the entire team. So if Alexa scored a quarter of those, she scored 7. If Brittany scored 2/7, she scored 28 divided by 7 is 4, times 2 is 8. Okay, let's add Alexa, Brittany, and Chelsea together. 7 plus 8 plus 15 is 30. So here's our problem. Alexa, Brittany, and Chelsea alone, just those 3 people, not even including the remaining 7, scored 30 points. Now that's not possible because the team scored 28. The team can't lose points. So clearly it's not 28. So let's try the next number. 28 times 2 is, oh, my mistake, 56. So what happens if the team scored 56 points? Then we can obviously expect 7 and 18 to double to 14 and 16. Okay? And 14 plus 16 plus 15 is equal to 45, which lets us know that the other 7 teammates scored 11 points. And remember, at the start of this question, we said that the maximum number of points that these 7 people can score is 14. And since 11 is less than 14, this is our set of numbers for this game. So to answer the question, what was the total number of points scored by the other 7 team members? The answer is 11. B. So the answer for question 23 is B, 11. So got problem number 24. In triangle ABC, point D divides side AC so that AD to DC is 1 to 2. Let E be the midpoint of BD and let F be the point of intersection of BC and line AE. Given that the area of ABC is 360, what is the area of EB and F? Right, so there's a lot of information here and this question is very complicated. So what I'm going to do is I will quickly color code what this information is trying to tell us. So what is it saying? Let's look at the first sentence again. In triangle ABC, point D divides AC so that AD to DC is 1 to 2. So AD, I'll color in red. Oh, we need the line tool for this one. AD in red, and I'll color code DC in blue. So DC like this. And it tells us that the ratio is 1 to 2. So if AD is 1, then DC is 2. If AD is 2, DC is 4. Now, second sentence. Let E be the midpoint of BD. So let E be the midpoint of BE to E to D. So the ratio of these 2 lines is 1 to 1. Perfect. Final piece of information, not final, second last, and let F be the point of intersection of line BC and AE. So where's BC? Where's BC? BC is down here, okay? And AE is over here. So where's point F? F is right over here. So what does that tell us? That means that if we extend A to E like this, then if we extend B to C like this, then they meet at this point that we're going to call F, okay? So given that the area of ABC is 360, what is the area of EBF? So let's last color code area EBF should be here. So let's color that triangle in like that. So we colored that in, and we just want to find the area of that triangle. Now there's a couple ways that we can solve this, but remember, we don't have a lot of time. We have 40 minutes to solve all of these questions, and that means that we don't even have 2 minutes to give to each of these questions. So we're going to have to really quickly come up with something. So this is the first thing that I see. I see ways that we can move these lines that we have extended. So I'll give you an example. A to E, we extended like this. What if I moved it to the right? So it's going to have the same slope. It's going to point the same direction, but it just moved. Now, remember, A to D and D to C have a ratio of 1 to 2. What does that mean? That means I can pick a point over here for me to move this really long line again, and I can do it one more time like this. So I can move this line how many times? 1, 2, 3, 3 more times. So that tells us that if B to C is the base of the large triangle ABC, then B to F is 1, 2, 3, 4, only a quarter of that. So if line B to C is the whole base, that means that line B to F is actually a quarter of B to C. Now that's really important. Let's write that in a ratio, because this question was in ratios. B to C compared to B to F is equal to 4 to 1. Oh, that's not 4 to 1. 4 to 1, like this. Okay? And let's do the same thing for the height. So what could I possibly extend for the height? I'm going to extend this line over here. B to D. I'm going to move that. And the way that I'm going to move that is using the same 1 to 2 ratio that we used earlier. So remember, line A to D and D to C have a ratio of 1 to 2. So that means that this point over here that I picked as the midpoint of D to C can yield another line. Oh, let's keep this as accurate as possible like this. So these two lines share the same slope. They're parallel to each other, and one more over here like this. So what that tells us is that this length over here, or another thing that it tells us is that the height of this triangle BEF is only a quarter. So there's 1, 2, and 3 pieces there. Is only 1/4 of the height of A to F, which is the height for the triangle ABC. So E to F compared to A to E is equal to not A to E. We want the whole height. So A to F is equal to 1 to 3. So now, finally, we can solve this question. Volume of a triangle, half times base times height. So 360 is the area of the large ABC triangle. Not volume, area. Area is equal to 1 over 2 times base times height. So we see the ratios of the base. So the base is 1 to 4. So a quarter of the bigger base and a third of the bigger height. So a quarter times a third is equal to 1 over 12. So using that ratio, we can find that the area of the smaller triangle EPF should be 1/12 of the area of the larger triangle ABC. So 360, let's do that right over here. 360 times 1 over 12 is equal to 30. So now we know that the answer to problem number 24 is B, 30. Okay, and now we have the last question. The last question says, Alice has 24 apples, and in how many ways can she share them with Becky and Chris so that all of them have at least 2 apples? Right. So, in order to solve this question, we need to think of these 3 different people as a set of numbers. So, what I will do is I will write something just like this: A, B, and C. So Alice, Becky, and Chris each have a minimum of 2 apples, but the total has to be 24. So what I'm going to do is I'm going to pick one person to have the least amount possible, which is just 2. So Alice will have 2, Becky will have 2, and that means Chris gets the rest, 20. Okay? What if I want to give one more to Becky? I do 2, 3, 19. Now can we keep running this where we give one more to Becky and one less to Chris? Yes, we can keep going until Chris gets 2, and obviously Becky gets 20 and Alice gets 2. So how many different iterations is this? So this shows us that if Alice can only get 2, so Alice is going to stay stagnant. She's only going to get 2, and Becky and Chris are going to be the one that, go up and down in the number of apples that they can receive. So that means that we have 19 different ways that we can order this, assuming that Alice sticks to just having 2 apples. Now, this is the thing. Alice can get more apples than 2, obviously. So in this case, we had 19 options. What if Alice gets 3? So if Alice gets 3, so same set of numbers like this. Alice gets 3, and Becky also just gets 2, and that means Chris gets 19, right? Right. So what that tells us is that Alice is just going to keep getting 3, but Becky will get 3. Chris will get 18. So Alice gets 3, Becky gets 4, Chris gets 17, and keeps going until Chris gets 2, Becky gets 19, and Alice has 3. So in this case, how many are there? How many options? There are 18 different ways that this can happen. Now, if we keep doing this trend, as an example, we give Alice 4 apples, Becky gets 2, and Chris gets 18, and then we switch around between Becky and Chris. How many more times can we really do this? We already know. We know that we can go all the way up until Alice gets 20, Becky gets 2, and Chris gets 2, which in that case, there is only 1 remaining. So what that tells us is that if Alice gets 2, and Becky gets 2, and Chris gets 2, and we keep switching around between Becky and Chris, we get 19 ways we can do that. If Alice gets 3, and Becky gets 2, and Chris gets 19, then Becky and Chris once again keep swapping, then we get 18. And using this trend, we can estimate, or we can predict that if Alice has 4, Becky has 2, and Chris has 18, then there's 17 ways to organize, all the way down to the point where Alice has 20, Becky has 2, and Chris has 2. So what we're going to do is 19 plus 18 plus 17 plus all the way down to 1, because that's what we predict the trend will look like. So how do we add something like this? Well, we have 19 unique numbers that we need to add, 1 to 19. And if we can use this formula, where the formula basically says that the first number and the last number multiply by the total number of unique numbers divided by 2. So 19 plus 1 multiplied by 19 over 2, which shows us that it's 20 times 19 over 2, which is 10 times 19 for an answer of 190. So using this way of pattern recognition, we can figure out that the answer to problem 25 is 190C. All right, so that was a complete overview of the solutions for the AMC-8 competition for 2019. You can find all my social media, and you can contact me at leothemathtutor@gmail.com. And if you have any questions, feel free to leave them in the comment section below, and I will get back to you on those questions or comments. So thank you very much for watching, and I will see you again on the next video. Bye-bye.